Hi, I'm Sam. I'm the founder of Third Eye, and I wanted to record this to talk about my vision for Third Eye, which goes beyond what we've created so far. But to give you some premise, what we've essentially created is an early warning system for organ failure in ICU by pioneering an evolving AI algorithm, one that designs itself. So given all the data that is stored in electronic health records, albeit text, live vitals, scans, etc., it predicts whether one or multiple organs will fail before onset, so that we can give clinicians that longer time window to intervene before it's too late. And upon validation on one of the largest hospital datasets from MIT, we were able to predict up to 48 hours in advance with an accuracy of 91%. But there was that part of my head that kept scratching on the fact that what if there's more? The fact that it's so good means that it's learning deeper insights. And if we can unlock the secrets it holds, we can create something truly phenomenal. And upon conclusion, I believe we can create a patient simulation. Now, what do I mean by that? Well, think about like self-driving cars or robotics industries, right? Before you roll out a product, they test in these simulations, and these simulations essentially model the physical world where the product is going to operate in, so they can test for every failure case scenario. And these simulations are used in multiple other industries too, like manufacturing, for example, where you can reduce the testing and development cycle to mere months before a product rollout. And that's essentially the aim. But the problem is something like that doesn't exist in the patient space, simply because it goes deep within how a simulation is created, which is just a bunch of mathematical functions that take in some input and give you some output. But there's no mathematical function that defines human physiology, at least not to that scale. But with artificial intelligence, we can learn that mathematical function. That's what machine learning is. They're basically function approximators. So for the first time, we can create those patient simulations simply by applying artificial intelligence. And that is what our model has learned. In order to predict the future of a patient, to predict organ failure, it has understood and modeled that patient's physiology to understand what the future will hold. It's simulating that patient in the clinical workflow. And by extending this, we can create the entire playbook, the full simulation, where future developers can create the chapters. So imagine the next time a patient comes into an ICU, thousands of different parallel simulations are calculating what different futures this patient will hold, so that we can pick and select the best one that can change it for the better. And the outcome of this would be in multiple folds. You would be updating the entire clinical stack, treatment definition, testing, development, clinical workflow optimization, the whole thing, by that single elegant solution, the patient simulation. So to all the crazies out there, number one, the investors. If you are crazy enough to join us and develop this patient simulation and take this entire $19 trillion industry with Storm, then join us. We need not just your capital, but your expertise in the commercial world, so that we're not just providing that technological advancement, but the advancement to the healthcare system as a whole and that economical impact. And to the crazy engineers who want to build better products than what currently exists, to explore new frontiers of machine learning rather than just exploiting what exists now, to create that machine learning 2.0 and flex that technical muscle, then join us, because we're going to need bright minds like you to create this simulation. And to all of our supporters, get this message in the right hands so we can get those right people and deliver this vision into reality, because everyone deserves a fighting chance.